For us to talk about the exponential function e to the x. This is a function that we saw back in section 1.6, so we're going to revisit it. It turns out this is one of the most important functions that we will deal with in all of mathematics, I want to say. I was going to say in this course, but really so much of math involves the exponential function e to the x. So, first thing I want to say here is that in section 2.5, there was a discussion of the fact that the limit as h goes to 0 of e to the h minus 1 over h is equal to 1. So, in that section, it was investigated numerically and graphically. It's the sort of so let's just realize here that when we plug in 0, we have a 1 minus 1 over, so that's 0 over 0. So this is a 0 over 0 indeterminate form, which is why I was in section 2.5. That's a 0 over 0 indeterminate form section. And so in that section, we just I omitted it from the video. You could have read about in the book. The point here is that that was done numerically. So we're going to take this as given. Actually proving this is a little bit outside the scope of the course. We're just going to take it as given. But let's use this limit in order to figure out what the derivative of e to the x is. So now let's say that our function f of x is e to the x. And let's figure out what the derivative is, and we'll want to take this limit as given for us in the near future. So the derivative here is, well, let's just write down the limit definition, as limit as h goes to 0 of f of x plus h minus f of x, all of that over h. So it's the limit as h goes to 0 of, so f of x plus h is e to the x plus h minus e to the x, all of that over h. And so now if we rearrange this a little bit, side note here, let's remember our exponent rules. E to the x plus h, we can rewrite this as e to the x times e to the h. So let's do that. E to the x times e to the h minus e to the x, all of that over h. And so now we've got factors of e to the x in the numerator. So let's factor that out. E to the x times e to the h minus 1, all of that over h. So what's going on here? Well, realize that this e to the x, this is essentially a constant multiple of this with respect to h. That this e to the x does not depend on h in the slightest. So we could move this outside. And what we're left with is, it's just the limit as h goes to e to the x times the limit as h goes to 0 of e to the h minus 1 over h. And we're going to take that as given, that that is equal to 1. So this is e to the x times 1. And so our derivative is e to the x. So what's unusual, what's special here? E to the x is, so the derivative of e to the x is e to the x. So what makes e to the x special? So there's lots of things that make e to the x special. The one that we just figured out here is the derivative of e to the x is e to the x. You know, it's a function whose derivative is itself. So that's a very unique thing. It's one of the things that makes e to the x so special. We'll certainly come back to and play around with e to the x later on in the course. but this is an important thing to note right now. So now stick away. We now know how to evaluate. We can now take the derivatives of e to the x. We've got that in our toolkit along with the power rule.